All right, so we're going to go through these questions. The best thing to do is first off collect all your terms. So ball falls to gain 30 joules of kinetic energy. So I put that down as EK is equal to 30 joules. The ball is a mass of 2 kilograms, and it's asking you from what height did it fall. Now, as we know, there is no equation that has got kinetic energy, mass, and height. However, remember that if we have a ball that's falling from a certain height, then the amount of kinetic energy it will have at the bottom will be equal to the amount of gravitational potential energy it had at the top, assuming 100% efficiency. So I can say that I actually have potential energy, I had potential energy of 30 joules as well. And also, let's not forget that the force due to gravity is 10 newtons per kilogram. So I can actually use this equation, EP equals m times g times h. Rearrange that for height. I do that just by swapping the top with the bottom. My height will equal 30 divided by 2 times 10, giving me a height of 1.5 meters. There's you over 20. Oop, I'm just double checking that. Yeah. 30 divided by 20. Okay, lovely. This is really important. Remember this. A rock is dropped from 10 meters, so a height of 10 meters, from a cliff in France. That means it's on Earth, and it strikes the ground, transferring 350 joules of energy to the thermal store. Energy in the thermal store is 350 joules. It's asking you what the mass of the ball was. And again, we don't have the full mass of the ball, but this is a rock. It's being dropped onto the ground, and then it's going to hit the ground. When it hits the ground, the kinetic energy is going to turn into a thermal energy store. And again, if we assume 100% efficiency, then the 350 joules will be equal to the amount of kinetic energy. 350 joules that was transferred to the thermal store will be equal to the kinetic energy, which will also be equal to the potential energy. It was in France, so it's on Earth, which means I can again say that gravity is equal to 10 newtons per kilogram. And I can use my equation, EP is equal to m times g times h. I want to find the mass of the ball, so I'll rearrange my equation. EP over g times h. Mass will equal 350 over 10 times 10, giving me a mass of 3.5 kilograms. Billy goes bungee jumping in Wales. It's his birthday. He normally has a mass of 60 kilograms, but he ate 0.5 kilograms of cake. So the mass of Billy is going to equal the 60 kilograms plus the 0.5 kilograms that he's got from eating his cake. Jumps off a bridge and gains 30,000 joules of kinetic energy. EK is equal to 30,000 joules. How long was the bungee cord? It's asking me for a distance in a bungee cord. Now remember that a distance is just a height that's vertical. A length is just a height that's vertical. So we can actually, instead of saying D equals however many meters, we'll say height is equal to however many meters. Because it's in Wales, it's on Earth, so the gravity is 10 newtons per kilogram. I want to find the height, and again, we can say that the kinetic energy is equal to potential energy. So I can use my equation EP equals m times g times delta h. Rearrange that for the change in height. Put in my numbers, 30,000 joules over 60.5 times 10. Now for this, I'm first off going to press A over B, then 30,000, and the down arrow, 60.5 times 10. Wow, he jumped 49.59 meters, the brave lad. Now because we got it in 1 decimal point up here, I'm going to return it in 1 decimal point as well, 49.6 meters. Sammy slides a slippery slide in East Park. The slide was 3 meters high. She gained 400 joules. And remember that because we're assuming that all of the energy from the top of a fall is equal to the, we're assuming that all the gravitational potential energy is equal to the kinetic energy in this. We're assuming 100% efficiency. as in none of the energy is wasted. That's why we can say that the gravitational potential energy is equal to the kinetic energy. So I can also say that the potential energy is equal to 400 joules. It's asking for her mass in kilograms. And don't forget, East Park is on Earth, so gravity is 10 newtons per kilogram. Rearrange this for mass. Mass is equal to 400 over 10 times 3. Mass is equal to 13 1/3. Wow, okay. Sammy is tiny. Mr. Patrick climbed up 2 flights of stairs and then slid down the banister to the bottom. Mr. Patrick had 400 joules of kinetic energy, EK, 4,000 joules. Energy at the bottom, and has a mass of 80 kilograms. How high were the stairs? I do not know. Remember, EK is equal to EP because we're assuming 100% efficiency. And gravity is 10 newtons per kilogram. EP, m times g times h. And I can use this equation because it has got mass and gravity and height. There's mass, pardon me. So again, I'll do AB, 4,000 over 10 times 80, 5 meters high. A dog in America has learned how to skateboard. At the top of a hill, the dog has 6,500 joules of GPE. Dog has a mass, 4.2 kilograms. What velocity was the dog going at the bottom of the hill? Well, just the same way that we can say that the gravitational potential energy is equal to the kinetic energy when an object falls, we can say that the kinetic energy is the same as potential energy. So I can say that that is equal to kinetic energy. EK equals 1/2 times mass times velocity squared. And well done for anybody who spent a bit of time figuring this out by themselves and who's able to rearrange the equations well. It's a good trick to learn. So for finding this out, I'm going to do square root sign, then a over b, and then I'm going to write down 6,500. And underneath that, I'm going to do 0.5 times 4.2. Press equals to. Oh, wow. Poor little doggy. About 90 miles an hour. 55.63 meters per second.